Welcome to this video. Today we will be introducing Surds. Now, Surds is a fancy word and you may not have come across it except in math class. But I'm going to take you through what Surds mean and how to solve any problem that has to do with Surds. So Surds check your ability to do two main things. First of all, your ability to split numbers into their multiples. But not just any multiples, multiples that contain at least one square. So first of all, you have to split your numbers into their multiples, and the multiple that you choose should contain a square number. Basically, with surds, we mostly deal with the square root of numbers. As you can see in the corner, I've given us three examples that we're going to work with today, and we'll see where we can get with them. The first one is the square root of 24. Ideally, 24 is not a square number. There is no whole number that you multiply by itself to get 24. However, if we look closely at 24, we can split it into the multiples of 24. We have 1 multiplied by 24. We have 2 multiplied by 12. We have 3 multiplied by 8. And we have 4 multiplied by 6. Now, in which of these multiple pairs do we have a square number? Well, we're going to overlook the obvious, which is 1, and then we'll go through the rest. 2 is not a square number, neither is 12, so that's out. 3 is not a square number, neither is 8, that's out as well. 4 is a square number, although 6 is not. But remember, I said you have to have at least one square number. So this works, which means that the square root of 24 can also be written as the square root of 4 multiplied by 6. At this point, what we can do is split up both numbers. Because they're combined by multiplication, we can split them up and they'll still be combined by multiplication. I know I just used a lot of words, so let's see how it works. So this becomes the square root of 4 multiplied by the square root of 6. We know the square root of 4, which is 2. Remember that 6 is not a square number, so we're going to leave it as it is. But since the square root of 4 is 2, what we'll then have is 2 multiplied by the square root of 6. That gives 2 root 6. So what we've done is we have moved from square root of 24 to a simpler surd, which is 2 root 6. Don't be confused, they are still combined together with a multiplication or a dot product. Let's go to our second example. For example B, we're working with the square root of 96. The same way we worked with the square root of 24 is the same way we're going to work with this one. So let's try to split 96 into the multiples. We have 1 multiplied by 96, 2 multiplied by 48, 3 multiplied by 32, 4 multiplied by 24, 6 multiplied by 16, 8 multiplied by 12. There's nothing for 9, there's nothing for 10, nothing for 11. So that's what we have. As before, we're going to run through and see which multiple pairs contains at least one square number. We already rule out the first one. 2 is not a square, neither is 48. 3 is not a square number, neither is 32. 4 is a square number, so we'll keep that for now. 6 is not a square number, but 16 is a square number. 8 is not a square number, and neither is 12. So in this case, we've established two possible ways that we can split square root of 96. We'll go through them one at a time. So the first would be square root of 4 times 24. Again, we'll then have square root of 4 multiplied by the square root of 24, which would be 2 multiplied by the square root of 24, giving us 2 root 24. We could even go further to simplify root 24 because 24 obviously can go smaller. But let's leave it for a while. Now, for our second multiple pair, we will have square root of 6 multiplied by 16, which is square root of 6 multiplied by square root of 16. Remember that even though 6 is not a square number, 16 is, and the square root of 16 is 4. So what we'll then have is 4 multiplied by root 16, which would give 4 root 16. There we have it. The beauty of surds is that if I wanted to go further with the result of our first pair, which is 2 root 24, remember that root 24 gave us 2 root 6 from our first example. So we could easily do 2 multiplied by 2 root 6, and that would be 4 root 6. So using the first or the second, we arrive at the same answer. Let's move to our third example. For our third example, we had the square root of 600. Now, we're going to have to start thinking quickly. And instead of going through all the possible multiple pairs that we can for 600, we're going to eyeball it a little bit. Already, I can see that 600 is 6 times 100. And 100 is a square number. So we'll have square root of 6 multiplied by square root of 100. And that gives, since the square root of 100 is 10, we'll have 10 multiplied by the square root of 6 or root 6, and that will be 10 root 6. You may wonder or you may ask, why are we not trying to go further with root 6? The truth is we can't, because 6 can only go into 1 multiplied by 6 and 2 multiplied by 3. And unfortunately, neither of these multiple pairs has a square number in it. So root 6 is the lowest we can go. So there you have it. In this video, we looked at surds and what we can accomplish with them. First, I said they test your ability to split numbers into their multiple pairs. And then you also have to identify the square numbers in those multiple pairs. So you need to learn to think outside the box. You need to learn to eyeball the numbers, just like I did in this third example, and you'll be well on your way. In the next video, we're going to look at other applications of surds and other questions that you might face when dealing with surds. But I hope you enjoyed this introduction, and if you have questions, feel free to put them in the comments.
Thank you for watching this video. I hope you enjoyed it.
If you have any questions or you need direct math tutoring, feel free to email us at durotutors@gmail.com. Please like this video, share, and subscribe. I'll see you in the next video. And until then, keep durowing.